Alright, here we're going to be talking about parallel lines and proportions. So this first one is dealing with a parallel line cutting through a triangle. It's called the side splitter theorem. It's just splitting these sides proportionally. So anytime we have a parallel line that cuts across a triangle, then it divides those sides proportionally. So I could say AE over EB is equal to AF over FC. So that's this length compared to that length. But more than that, I could even say that AE compares to the entire length the same way AF compares to this entire length there. So AE over AB is also equal to AF over AC. And actually the same is true with this part. If I wanted to use that one, I could say EB compared to the entire length of AB is equal to FC over AC. Just important that you use matching parts. This part matches up with that one, and we can use that in any of these proportions really, as long as we're comparing it to another part that corresponds with another part there. The same is true when we just have two lines that don't connect, so it doesn't actually have to make a triangle. These parts are still proportional. So when we have parallel lines that are cutting across these transversals, these sections are divided into proportional sections. So AC over CE is equal to BD over DF. And the same was true, similarly, the way I use the entire length here, I could use the entire length here. I could talk about the entire length of AE over AC or CE. That's equal to the entire length here of BF to, I used AC, so I need to use BD. So really that proportion is true for any segments that you want to pick in here, the entire thing or each part. Either way, it's proportional. And actually, this is kind of redundant from previous units. We know that if these are parallel, then these angles are corresponding. So by angle, we know that these two triangles are similar. So we know we could set up these proportions. It's just setting it into a formal theorem. Alright, so let's use that. So if I'm comparing on this side 7 over x, on the other side of those parallel lines, really on the other side of the triangle, continued through those parallel lines, we'd have to compare 6 to not the full length there, but just 21. 27 is the entire length, 6 is just that part, so this part's 21. So 7 over x compares to 6 over 21. Then we can cross multiply, get 6x equals 147, and x is 24.5. If you wanted to use the entire length here, let's say just for some reason you want to use 27 there, you could say 6 over 27, 6 compared to the entire length, that would be equal to 7 compared to this entire length, which we could label as the expression x plus 7. That's more complicated because we have an expression in here. That's definitely easier, but whichever way you see it more naturally, it's up to you. On this one, we're going to need to use these expressions. 6 compares to 21. That section compared to that one is equal to this section compared to this section, which is x minus 1 over 3x plus 1. Now we're going to cross multiply, and remember we have to multiply into the entire quantity here. So we're going to do 6 times 3x plus 6, plus 1 equals 21 times x minus 1. So this is 18x plus 6, and this is 21x minus 21. Now we'll combine like terms, we get 27 on this side and 3x on that side, so x is 9. Those are both dealing with triangles. These are both dealing with just parallel lines cut by transversals. It's the same thing though. 28 compares to, I'm going to find this length, that's 64. So 28 over 64 is equal to this length compared to this length, 31.5 compared to x. So we're going to cross multiply. You get 2016 equals 28x, and so x is 72. If you were to set this up wrong, you would end up getting a smaller number. Let's say by accident you flip this side. You would end up getting a smaller number than 64. But that wouldn't really make any sense. If this side is getting bigger, going from 28 up to 31.5, that side also has to get bigger. All right. Same kind of relationship. 2x plus 2 over 21 equals x plus 3 over 12. We're going to cross multiply into this entire quantity and get 24x plus 24. Cross multiplying here gives us 21x plus 63. So combining like terms gives us 3x equals 39, and x is 13. Alright, all of these u-tries are pretty much exactly the same. Just make sure you're always comparing individual parts to its corresponding opposite part, or the entire length to another entire length. Alright, if you need help, let me know.